guys, and welcome to class. So you have a few items in front of you that you're going to have to do today. There's one packet that isn't due until Monday, possibly Tuesday, because it is kind of big for you to do on your own. But we're going to walk through everything right now together. First things up is your article. I'm going to read you your article, and then I'm going to read you your questions, okay? There's only 10 questions, don't panic, and the article's kind of short. So let's get on to the article first, and then we'll go over the packet together. All right. The name of the article is Mount Pinatubo. 2 points for anybody who can pronounce that correctly. And the Ring of Fire. On July 16, 1990, a large earthquake struck Luzon, an island in the Philippines. The earthquake devastated cities for hundreds of miles around, killing more than 1,600 people. Yet the destruction was not over. 2 weeks later, residents of Luzon discovered steam coming out of the volcano called Mount Pinatubo. But when scientists inspected the volcano, they couldn't find any evidence that the volcano was going to erupt. However, March 15th of 1991, villagers on the northwestern side of the island were startled by a series of earthquakes. The earthquake continued until 2 weeks later when Mount Pinatubo began to rumble. On April 2nd, the mountain sent an explosion of steam, water, ash, and rock into the air. Over the next several weeks, it continued to belch volcanic ash into the air. Scientists detected increased levels of carbon dioxide, a sign that liquid hot magma was nearing the surface. By June 7th, a dome of lava 130 feet high and 660 feet across had formed on the surface of the volcano. That's pretty interesting. 5 days later, the volcano erupted. Hot volcanic ash rose about 20 miles into the air, and an ash cloud of almost 50,000 square miles blanketed the island in darkness. The summit of the volcano was blown off, replaced by a new hole 1.6 miles wide. 847 people surrounding communities died. Most of them when they were on their roofs, blanketed under the weight of the wet ash, had collapsed. Geologists would later rank this eruption of Mount Pinatubo as the second largest volcanic eruption in the 20th century. While scientists have never determined whether the earthquake in 1990 was directly caused the volcanic eruption a year later, the two events were generally considered to be related. Although it's difficult to predict when or where the earthquake or volcano eruption will strike, these events occur in patterns. Did we talk about that today? I think we did. Mount Pinatubo was located on the Ring of Fire. The Ring of Fire is a horseshoe-shaped zone. It's a shaped zone. It's shaped like a horseshoe. Characterized by earthquakes. So there's a lot of earthquakes there. Remember how we were talking about the San Andreas fault lines where they moved? So there's loads of earthquakes in this section over here on this side of the planet. And which side of the planet? The Pacific Ocean. Again, we talked about that today. See, the things that we talk about, like seem to keep popping up. The Ring of Fire begins on the southern edge of South America and runs north along the western coast of the Americas, cuts across the edge of Alaska, the southern edge of Alaska, and down the eastern edge of the Urals before swimming in a series of deep trenches several thousand miles off the coast of Australia. So 75% of the world's active volcanoes are located on this ring. And almost 90% of the world's earthquakes happen here. That's pretty interesting. Okay, so we've got a little bit more to read. The reason why so many earthquakes and volcanoes eruptions occur here has to do with the plate tectonics. On the surface of the earth is a patchwork of enormous plates, atop which all geographic features seas, oceans, fields, mountain ranges, they all sit. These plates are in constant motion, although they move very slow, under 6 inches per year. These plates separate, collide, or slip past each other along their boundaries. So they move very slow. If they move fast, then we have a problem. But they move very slow. Okay. These movements are referred to plate tectonics. Massive events such as earthquakes and volcanic eruptions can occur along those plate boundaries. Now, we've discussed these. We discussed these earlier this afternoon when we were in session. So, like I said, we're going to continue on talking about algae and earthquakes and how they're linked with dinosaur breath. Seems really confusing, but I kind of like it. Most earthquakes occur in areas often close to the plate's boundaries. Areas that are in the middle of the plates generally do not suffer from these same forces. This is why there are earthquakes in San Francisco, which is close to where two plates slide past each other. Ooh, that's the one, the San Andreas plates I was telling you about, because what happens if you watch the movie with a rock in it? San Francisco is right there next to San Andreas, and guess what happens? They have a massive earthquake. Yep. Slide past each other, and usually not in Chicago. 1,000 miles away from any plate boundary. So Chicago, not going to have an earthquake. Knock on wood, right? Similar volcanoes tend to form near the plate boundaries where there's more movement on the Earth's plates create these events, which are opening the Earth's surface. So think about it opening like a flower. Magma liquid rock located below the Earth's surface can rise toward the surface of each of the Earth and erupt out of volcanoes. The island of Luzon, where Mount Pinatubo erupted, is near a location where a sea plate has been sliding under a continental plate. Ooh, that was scary. So you have two different plates sliding around. So you have your cotton plate on top of your tectonic plate, and it's just doing this number, and that's never good. Ooh, patterns. The location of the mountain range is also closely linked to the activity of plates. The collision of two continental plates has formed Earth's tallest mountain ranges on land, such as the Himalayas. Now, I think some of you had a question about Mount Everest and the Himalayas. So now I think you have your answer. So it's that third to last paragraph right there should really help you with that. How did Mount Everest come about? Well, you had those two continental plates, and guess what? They did this number. And when those two plates, they don't slide anymore, they keep sliding and sliding, and they just crash into each other, and that's how you create a mountain. These mountain chains, and they come in chains, because when one crashes, think about a little ripple effect, okay? Are essentially crumbled up parts of continental plates formed when two continental plates crash against each other. Again, if you take two big plates from under the water and they smash into each other and they come up out of the sea. Something you don't think you would survive, but I think it's pretty cool. Deep ocean trenches, such as the Mariana Trench of the Pacific Ocean, can also form along plate boundaries. The Mariana trenches reach almost 7 miles down. That's a pretty good long way down. If you look on a detailed map, one that includes physical features such as mountain ranges and trenches, you will begin to see patterns. You may even be able to guess where some of the giant continental plates are located. Okay, so now that we've gone through our whole article together, let's go ahead and go up. I'm on my computer doing this because I didn't bring my hard copy home. And I'm going to look at your question set. Okay, so these seem pretty easy. So question number 1 says, what happened in 1990 and in 1991 on the island of Luzon? Okay, very good. Question 2. What does this passage describe? So what are we talking about here? Are you reading this? Okay, good. Question 3. Most earthquakes occur in areas close to where the tectonic plates meet. There are earthquakes in San Francisco. What can be concluded from this information? Okay, I'll give you just a second. It's a conclusion. You got it? Very good. All right, number 4. Why might the 1990 earthquake and the 1991 volcanic eruption of Luzon be related? Doop, 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 doop. Did you get it? Okay, perfect. What is this passage mainly about? Yeah, that was pretty easy, you're right. Number 6, read the following sentence. 5 days later, the volcano erupted. Now noted, the word erupted there is in bold letters, so maybe that's important. Hot volcanic ash rose about 20 miles into the air. What do you think the word erupted means? Come on, guys, you know this one. This is a 7th grade, 6th grade word. Okay, good job. Number 7, choose the best answer. Choose the answer that best completes the sentence below. First, there was an earthquake in Luzon. No, it's signing me out. Okay, so question 7 says, choose the answer that best completes the sentence below. First, there was an earthquake in Luzon. Blank, there was volcanic eruption. So what is it? Okay, I hope you chose correctly. All right. Number 8, what is the ring of fire? Okay, take your time, write that one down. Number 9, why do so many earthquakes and volcanoes occur around the ring of fire? And number 10, this is also a written answer. Read the sentence from the passage. While scientists have never determined whether the earthquake in 1990 directly caused the volcanic eruption a year later, the two events are generally considered to be related. What evidence from the passage supports the argument that the earthquake and the volcanic eruption in Luzon we're probably related. Okay, did you guys get all that? Good. Now we are going to take a pause from that for just a second. And now that you have that all done and you're all finished, now let's go ahead and open up this really fun, exciting little thing that I got for you guys. So this is called my science root monster. Now, when I taught science before, we did this and we did this over a time period. And this, again, is something to do over a time period. This, I know, I promised I wouldn't give weekend homework, but you guys really need these root words and you need to learn the science language, okay? So, science root project, okay? So, he's a little monster. Of course, you guys know how much I love my little monsters. So, you guys will be making a creation. So, the very first page that you're looking at is a whole bunch of words and boxes, and it doesn't seem like they make any sense. But if you look at them, it actually tells you. So it tells you colors, and it tells you in some kind of a way, and then it tells you in what you know is English, right? So it's going to be kind of fun for everybody. So we're going to figure out what we're going to do. Okay, the objective. The purpose of this assignment is to learn how to use root words to describe the meaning of science terms. To do this, you will be completing a multi-skilled section, including creating your very own root monster. Refer to the table below for common science root words and their meaning. So you look at all of these, and you're going to need to know these. Believe it or not. You're going to, I know, I've heard it. When am I ever going to need to know these root words? Well, you're going to need to know them all through high school science. So, I don't know, maybe I become your high school science teacher in the 10th grade, and I give you this one, but the 10th grade version of the same project, and I don't give you this whole root word. You have to already know them. Yeah, so there'll be times. So, we can look at some of, let's see, which ones do we already know? We know micro means small. Let's see, dipple, that means 2. Uni means 1, obviously. Let's see, bio means life. That's why it says biology. It means biology is the study of life, or a life study. There's so many different things in here. I love this first page. It's so cute because it gives you what you're gonna need. All right, section 2, matching. All right. You can use science root words to figure out the meaning of difficult science vocabulary. For this activity, you will need to match, okay, you're going to match some words here, the scientific term with the correct definition by analyzing root words. So, can we use that front piece of paper? Yes, we can. So you're going to look at the terms biology, and I think I just told you what biology means, because bio means life, and ology means study. So it's a study of life. So let's see. Something means terrible lizard. Oh, which one means terrible lizard? ICH says terrible lizard. Let's see. Huh. Doob-a-doob-a-doob-doob-doob-doob-doob. Doob-doob. I'm waiting for one of y'all to yell it out. Is it dinosaur? Is it dinosaur? I hope it's dinosaur, because I really like dinosaurs, because we're learning about dinosaurs. Well, let's see. Terrible lizard is dinosaur. That's why he's called a T-Rex. He's the king of the terrible dinosaurs. Yep. Horrible, terrible lizards. And let's see, what other one? Let's see. Nearer the front. Oh, okay. So I'm looking at the definitions. I'm looking at the words. Not only can we use our root words page, but we could also use the Sciencesaurus that you have. You know the bookshelf that's inside my desk? Those little green books? You can use those books. And all of these words are inside those books. Okay? So we're going to pop on down to section 2. Section 2, word breakdown. Each question below contains one science vocabulary term. You must create your own definition. You understand that? You must create a definition for each word by using the root from within the term, okay? So let's look at number 17. The suffix side means to kill. The word is insecticide. Yeah. Define the word. What's an insecticide? I hope y'all do know what number 17 is, because that one is super easy. Okay. Section 3. Design your root monster. Oh, we're so excited. Use at least 5 scientific root words to create your own unique science monster. You must include the scientific name as well as the English translation of your root monster above your colored drawing, okay? So on the next page, if you're looking at it, it should be a blank page, really cute. So you must put it in there, okay? Scientific names are made of 2 words. First word is always capitalized, and the second word is not capitalized. Scientific names are also in italics or underlined. The scientific name you give your monster must match your monster's characteristics, including the 5 root words. For instance, if you have the scientific name labeled there, ooh, that's a big long one. It translates into blue, 2-eyed, 3-horned, black-winged monster. Okay? If that's what you come up with, you must put it in that terminology, plus the English version. All right? Now, I'm looking with you at my root monster, so it's a really cute little page. You can color that in and make it look like slime. And section 4, the monster's story. Okay? So we're going to look at the monster's story and see what he is. Use at least 7 science root words to write a creative story that involves your root monster. Each science root must be underlined. The roots you choose must fit logically and should be used correctly within your story. Ready? And our very last little page here that we have that we're going to go over is the skills, okay? Let's see, directions. Complete each Freyr's model by choosing one scientific root word. For each root word, you must write the definition, draw a picture, and, you know, the draw a picture part. Give an example, okay, containing the root word, and write a sentence correctly using one of the samples. Now I see 1, 2, 3, 4, 5, 6. That's not too bad. You guys have done worse stuff than this. All right, my kiddos. I shall see you on Monday. If you followed my YouTube channel and you're watching this in class, I am in my jammies. So I want you guys to have a great weekend, and I will see you on Monday.